So let's talk about selection of terms in a geometric progression. There will be some times when we will be required to select a finite number of terms in a geometric progression. So there's a particular way of choosing the terms. So let's say we have three numbers of terms. Then how do we select the terms? To select the terms, all we have to do is consider three terms, a over r, a, and a r. So these three terms are going to be in geometric progression and they are going to have a common ratio of r. You can verify it by taking the second term and dividing it by the first term to get a common ratio of r. Or similarly, we can take the third term and divide it by the first term to get a common ratio of r. What if we want to select four number of terms? So if we want to select four number of terms, then we will be selecting four terms in such a fashion that the first term will be a over r cubed, followed by a over r, then the next will be ar, and the fourth will be ar cubed. Now here, if we select the common ratio, to find out the common ratio, all we have to do is take any term on this particular GP and divide it by the previous term, and this is going to give us a common ratio of r squared. And sometimes we might need to select five terms in the geometric progression. So the five terms will be a over r squared. This will be the first term, followed by the second term, a over r. Then the third term is going to be a. The fourth term is going to be ar, and the fifth term is going to be ar squared. So in this case, the common ratio is going to be equals to r. Then if the number of terms, so this is a very special case when you have 3, 4 and 5 terms. If the number of terms are not given, then we can select ar squared, ar cubed, and so on. This is only when the number of terms are not specified. So let's try to apply this particular idea with the help of few examples. So here we need to find three numbers that are in geometric progression, and it's given that the sum of the three numbers is 38 and the product is 1728. So let's specify the numbers first. So let the numbers be a over r, a, and ar. These three numbers are in a geometric progression where a represents the first term and r represents the common ratio. Now it's given here that the product, which is a over r multiplied to a times r, this product is given as equals to 1728. And it's given here also that the sum, that is a over r plus ar, this is equals to 38. Now we can see here that r and r will get cancelled. We have a cubed, and 1728, that's actually the cube of the number 12. So that means r, if we take the positive cube root, then our first term a value, that's going to be equals to 12. So now that we have the value of 12, we can use this to solve this particular equation. The sum, we can take a as the common factor. We have 1 over r plus 1 plus r. This is equals to 38. So a value, that's 12. 12 multiplied to, we will combine the three terms within the parentheses. So we're going to get 1 plus r squared divided by r. So this is equals to 38. Now further simplification gives us 12 plus 12r plus 12r squared equals to 38r. So that means we now have 12r squared. So 12 minus 38, so this is going to be negative 26. So negative 26r plus 12 is equals to 0. Or we can also take 2 as the common factor. So we have 2 times 6r squared minus 13r plus 6 equals to 0. Since 2 cannot be equals to 0, we are going to get 6r squared minus 13r plus 6 equals to 0. Now 6 times 6, so this 6 multiplied to this 6, that's 36, and the other factors will be 9 and 4, which means we can say that 9 times 4 is equals to 36. There's a reason why I've considered 9 and 4, because 9 plus 4, that's 13, which can be used to split the middle term. So we are going to get 6r squared minus 9r minus 4r plus 6 equals to 0. So from the first term and the second term, we can take 3r as the common factor. So we have 2 times r minus 3. And we can combine the third and the fourth term by taking negative 2 as the common factor. So we have negative, within the parentheses, we have 2r minus 3, which will be equals to 0. Now we can combine these two terms by taking 2r minus 3 as the common factor, and this will get multiplied to 3r minus 2. Now the product is equals to 0. So that's true whenever one of them is 0 or both of them are equals to 0. So we can obtain the value of r. So r value will be either 3 over 2 or it can be r equals to 2 over 3. So we have obtained the value of our common ratio r. Now we also have the value of our first term, which is 12. So let's consider the first case when a value is 12 and our common ratio is equals to 3 over 2. Remember, our number that we chose were a over r, a, and ar. That means we will now get, so a over r means we have 12 divided by 3 divided by 2. So this is going to give us 8. So our first term is going to be 8. Then we have a, so our a value, so this is a over r. So our a value will be equals to, so we've already obtained the value of a, so this is 12. And finally ar, so this is going to be a times, so 12 times 3 over 2. So this is going to give us 18. So that means 8, 12 and 18. So these are the numbers that are going to be in GP. In the second case, what we'll do, we'll consider the other value of our common ratio r. So when we have our a value equals to 12 and our r value is given by 2 over 3, then a over r, so this is going to be equals to 18. A will be equals to 12 and ar is going to be equals to 8. So that means the other geometric progression is going to be 18, 12 and 8. So this is also going to be in GP. So this is how we can obtain three numbers that are in GP such that their sum is given as 38 and their product is 1728. So let's move on to the next problem. So in problem number 2, we have to obtain three numbers that are in geometric progression such that the sum of the three numbers is 13 and the sum of the square is 91. So this time we're going to do it a little bit differently. So instead of choosing a over r, a and r, ar as the three numbers, so here we're going to consider a, ar and ar squared be the three numbers that are in geometric progression. Now it's given here that the sum a plus ar squared, the sum of the three terms is 13. This is equation number 1, and the sum of the squares is 91. That means a squared plus a squared r squared plus a squared r raised to the power of 4. So the sum is equals to 91. This is equation number 2. Now we are going to solve these two equations to obtain first the value of a followed by the common ratio, which is going to help us obtain the value of the three terms. So let's begin. So starting with equation number 1, what we'll do, we'll square both sides of the two equations. So we have a, so let's first take a as the common factor. So we have a multiplied to 1 plus r squared. This is equals to 13. Then we're going to square both sides. So we have a squared multiplied to 1 plus r squared whole squared. So this is equals to 13 squared. So we have a squared time. Now we're going to expand 1 plus r squared whole squared. So this is going to be 1 plus r squared plus r raised to the power of 4 plus 2 times r plus 2 times r cubed plus 2 times r squared. So this is going to be equals to 169. So this can be further simplified as, so we'll take a squared and multiply it to the first three terms. So we have a squared multiplied to 1 plus r squared plus r raised to the power of 4. Plus, then we're going to multiply a squared to the rest of the three terms. So here we have a squared multiplied to the rest of the three terms. However, we can take 2r as the common factor from each of the three terms. So we have 2 times r taken out. So this will now get multiplied to 1 plus r squared plus r. So this will be equals to 169. Now, in equation number 2, if we take our a squared as the common factor, so we have a squared multiplied to 1 plus r squared plus r raised to the power of 4 equals to 91. So that means we can use this value instead of the first term. So this is going to be 91 plus. Now if we look at this second term, so here the second term is, if we say we have 2 times a times r, which is multiplied to a times 1 plus r squared plus r, and this value is actually 13. So we can replace this entire value with 13. So this will be equals to 169. So that means we will now have the 13 times 2ar will be 26ar, which will be equals to 168 minus 91. So that's going to be 78. So ar will be equals to 78 divided by 26, which is equals to 3, because 26 times 3 is 78. So we have obtained the value of a times r equals to 3. Or if we want to write in terms of r, this is simply going to be 3 over a. So let's label this as equation number 3. Now coming back to equation number 1, the equation number 1, we had a plus ar squared. So this came out to be equals to 13. This was already provided to us. So if we take a as the common factor, we have 1 plus r squared. So this is equals to 13. Now what we'll do, in place of r, we are going to replace it with r over a. We have a times 1 plus 3 over a plus, so r squared will be 9 over a squared, which is equals to 13. So multiplying throughout with a, so we have a plus 3 plus 9 over a equals to 13. Again, we're going to multiply both sides with a. So we're going to get a squared plus 3a plus 9 equals to 13a. So we'll transpose 13a to the left hand side. So that's going to give us negative 10a plus 9 equals to 0. So that means we have a minus 9 multiplied to a minus 1. So this is going to be the factors of a squared minus 10a plus 9. On solving, we're going to get a equals to 9 or a equals to 1. Right. So we have obtained two values for our first term. So using equation number 3, so r is equals to 3 over a, we can also obtain the common ratio. So let's use that. So when a equals to 9, this implies the r value, which is simply 3 divided by a. So that means we're going to get 3 over 9, which is equals to 1 over 3. And when, for the other case, and when a value is equals to 1, this is going to give us r value equals to 3 divided by 1, which is simply equals to 3. So we have obtained the first term in the common ratio. So let's now find out the three numbers. So our a value is 9 and our common ratio is 1/3. So here we'll have to find out the value of a, ar and ar squared. And for the other one, we have a value equals to 1 and r value equals to 3. So similarly, we'll obtain these three values. So let's find them out. So we have first term is a, which is 9. Then we have a times r, so 9 times 1/3 will be 3. And we have ar squared, so this is going to be equals to 1. Next, here the first term is 1. Then we have a times r, so 1 times 3 will be 3. And then 1 times 3 squared will be equals to 9. So that means our three numbers will be 9, 3 and 1. So let's say 9, 3 and 1. These three numbers are in geometric progression. Also, we'll get the other set, which is 1, 3, 8, 9. These three numbers are also going to be in GP, which follows the same criterion that the sum is equals to 13 and the sum of the squares equals 91. Let's move on to the third problem. Problem number 3. We need to obtain three numbers that are in GP, and also those numbers are in such that the sum of the products in pairs is 156 and the regular product is 216. So we'll begin by considering, since we are provided with the product, so it will be wise to choose the numbers as a over r, a and ar, be the three numbers, be in geometric progression. So whatever is given to us, let's note them down. So it's given that their product a over r multiplied to a multiplied to ar So this is equals to 216. This is equation number 1. But let's further solve it. So we have r and r getting cancelled. So we have a cubed equals to 216. And we know that 6 cubed, that has a value of 216, which gives us a value of our first term, a. So we will set it aside and label this as equation number 1. Also, it's given that their sum of the products in pairs. Sum of the products in pairs means we'll take the first term and multiply it to the second term, add it to the product of the second term and the third term, and finally add it to the product of the first term and the third term. So this product is given as equals to 156. So let's solve this. So we have a squared divided by r plus a squared times r plus a squared. So here r and r gets cancelled. This is equals to 156. So here we can take a squared as the common factor. So we have 1 over r plus 1 equals to 156. We have already obtained the value of a here. So we'll replace this value of a with 6. We're going to get 36 multiplied to 1 over r plus 1. This is equals to 156. Now, we know that 12 times 3 is 36 and 12 times 13 is 156. So we have 3 multiplied to 1 over r plus 1 equals to 13. Now let's multiply both sides with r. So we have 3r multiplied to 1 over r plus 1. This is equals to 13r. Now 13r plus 1 times 1 over r. So that's 3 plus 3r squared plus 3r. This is equals to 13r. I will solve for r. So we are going to get 3r squared minus 10r plus 3 equals to 0. So this will be, let's split the middle term. So we have 3r squared minus 9r minus r plus 3 equals to 0. We'll take 3r as the common factor and combine the first and the second term to get r minus 3. We'll take negative 1 as the common factor and combine the third and the fourth term to get negative 1 multiplied to r minus 3, such that we now have 3r minus 1 multiplied to r minus 3 equals to 0. So either r minus 1 equals to 0 or r is equals to 3. So solving for r, we get two values. So r could be equals to 1/3 or r could be equals to 3. So we have already obtained the value of our first term, a equals to 6. So let's find out the geometric progression. So we'll consider the first case, a value equals to 6 and the r value equals to 1/3. In the second case, we have a value equals to 6 and the r value equals to 3. So here we'll have to obtain the values of our first term, which is a over r, then followed by a, and the next term is a r. So let's find out the value. So a times a divided by r, that means 6 divided by 1/3 is going to be 18. Then the first term is 6 and we'll have 6 multiplied to 1/3, that's going to be equals to 2. Then we have 6 times 3, so this is a 6 divided by 3, so that's going to be 2. Then we have the first a, then we have a times r, which is going to be 18. So these are the 3 numbers that are in geometric progression. Let's move on to the next problem. Problem number 4. We need to obtain 4 numbers that are in a geometric progression, and it's given that the sum is 85 and the product is 4096. So let's begin. So we'll choose our numbers carefully. So let the numbers be a over r cubed. Then we have a over r followed by a times r and a r cubed. So these are the 4 numbers that are in a geometric progression. Now it's given that the product of these 4 numbers or these 4 terms is 4096. So a over r cubed multiplied to a over r multiplied to a over r times a r cubed. So this is equals to 4096. So here r cubed times r, this is r raised to the power of 4, so this gets cancelled. All the r values gets cancelled. We have a raised to the power of 4 equals to 4096, and 4096 is simply 8 raised to the power of 4. So that means we have a equals to 4, a8. So let this be number 1. So we have obtained our first term. Our next task will be to obtain the value of the common ratio. For that, we will use the case that their sum is 85. So it's given here that their sum, which is a over r cubed plus a over r plus ar plus ar cubed. So this value is equals to 85. So what we'll do, we'll take a as the common factor from each of them. So have a multiplied to 1 over r cubed plus 1 over r plus r cubed. This is equals to 85. Now we've been already obtained the value of a here, which is 8. So we can divide both sides with a, and this is going to give us 1 over r cubed. So we'll take 1 over r cubed and r cubed will combine in these two terms plus the second and the third term. So that will be 1 over r plus r equals to 85 divided by the first term a, which is value 8. Now we know that a cube plus b cube, so this is given by a plus b whole cubed minus 3 times a plus b times a b. So using this formula, we can expand 1 over r cube plus r cube. So 1 over r cube added to r cube. So according to this formula, we are going to get 1 over r plus r whole cubed minus 3 times 1 over r plus r and a times b. So that's actually 1 over r multiplied to r, which is simply going to be equals to 1. We will substitute this value here. So that means we are going to get 1 over r plus r whole cubed minus 3 times 1 over r plus r plus, and we already have this 1 over r plus r. So this is going to be equals to 85 divided by 8. Now we have 1 over r plus r whole cubed. So combining the second and the third term, we're going to get negative 2 times 1 over r plus r, which is equals to 85 divided by 8. Now, in order to find out the value of r, so we are going to make a substitution here. So let's suppose that 1 over r plus r, that value is equals to x. So that means we're going to get x cubed minus 2 times x equals to 85 divided by 8. Or simply, we have 8x cubed minus 16x minus 85 equals to 0. So here 8x cubed minus 16x minus 85, this factorizes as 2x minus 5 multiplied to 4x squared plus 10x plus 17 equals to 0. Now we get from here, we can have the value of 2x minus 5 equating to 0, which is going to give us x equals to 5 over 2. Now since we have considered x to be equals to 1 over r plus r, so we have 1 over r, and also 1 over r plus r will be equals to 5 over 2. Now multiplying throughout with r, we're going to get 1 plus r squared equals to 5 over 2 times r. Then multiplying both sides with 2, we have 2 plus 2r squared equals to 5r. But rearranging the equation, we have 2r squared minus 5r plus 2 equals to 0. So that gives us 2r squared minus 4r minus r plus 2 equals to 0. So we can combine the first and the second term by taking 2r as the common factor. So we have r minus 2. Then we can combine the third and the fourth term by taking negative 1 as the common factor. So negative 1 times r minus 2 equals to 0. So this is going to give us r minus 2 times 2r minus 1 equals to 0. Solving for r, we're going to get two values. So r could be equals to 2 or r could be equals to 1 half. So I've already obtained the value of a. The a value was equals to 8. Now we are ready to obtain the numbers. So let's begin. So we have, well, consider the case a value is equals to 8 and r value is equals to half. In the second case, we have a value equals to 8 and r value equals to 2. We need to obtain the value of a over r cubed. Then we followed by a over r. Then we have ar and ar cubed. Let's plug in the values. So 8 divided by half cubed. So half cubed is 8. So this is going to be 64. Then we have 8 divided by half. So that will be 16. 8 times r, that means 8 multiplied to half will be 4, and ar cubed will be 8 times half cubed, which is 1. And we have 8 times a over r cubed, so this is going to be 1 followed by 4, and then we have 16 and 64. So these are the two geometric progressions. So we have the first one, which having the numbers 64, 16, 4 and 1. These are in GP, as well as 1, 4, 16 and 64. So these are also in geometric progression. Now let's do another final problem. Problem number 5. We need to obtain 3 numbers that are in a geometric progression such that the sum of these 3 numbers is going to be 70. And also when we take the extremes and multiply it by 4 and multiply the mean by 5, then the resulting sequence is an AP. So this is a condition. So using these conditions, we need to obtain these 3 numbers. So let the 3 numbers be A, AR and AR squared. So instead of taking A over R, A and AR, I'm taking here A, AR and AR squared, because here we are only given the sum. We have not been mentioned about the product. So that works whenever we are given with a product. So let these 3 numbers be in a geometric progression. So from condition number 1, so we have A plus AR squared. So this is equals to 70. So this is equation number 1. And it's given that when we take the extremes and multiply it by 4, so we have 4A AR squared, and the mean, which is the middle term, that's multiplied by 5. So these 3 numbers are in arithmetic progression. Fine. Now if they are in arithmetic progression, then the common difference must be equals. That means second term minus the first term. This must be equals to the third term minus the second term. 5AR and positive 5AR, this will combine to give us 10AR equals to 4AR squared plus 4A. Now we can get rid of the A from both sides by taking A as the common factor. So let's take 2A. The 2A will be multiplied to 5 times R equals to 2A multiplied to 2 times R squared plus 2. So here we have 5R equals to 2R squared plus 2. Now we can solve this equation because this only has R terms. So we have 2R squared minus 5R plus 2 equals to 0. This is a simple quadratic equation. We can split the middle term to have negative 4R minus R plus 2 equals to 0. Combining the first and the second term by taking 2R as the common factor. So we have R minus 2. And we can combine the third and the fourth term by taking negative 1 as the common factor. So we have negative 1 times R minus 2. This is equals to 0. And finally, we're going to get 2R minus 1 multiplied to R minus 2 equals to 0. So R could have 2 values. R could be equals to half, or R could be equals to 2. Now, coming to our first equation. So here we can take A as the common factor. So we have A times 1 plus R squared equals to 70. Now we have already obtained 2 values of R. So let's say when R value is equals to 2, then we have A multiplied to 1 plus 2 plus 2 squared. So this is equals to 70. So we have A multiplied to 1 plus 2 plus 4. So we have 4, 5, 6, 7. So that means we have 7A equals to 70, or A value is equals to 10. Now when A value is equals to 10, then the 3 numbers will be, the first term will be 10 followed by A times R. So 10 times 2 will be 20. And the third term will be 10 times 2 squared, so this will be 40. So 10, 20 and 40 are in geometric progression. Then we're going to the next case when R value is equals to half. So we have an equation which is A multiplied to 1 plus R squared equals to 70. So we have A times 1 plus R. So that means 1 divided R will be half plus 1 divided, then we have R squared. So this is 1 over 4. So this is equals to 70. So we have A multiplied to our common denominator will be 4. So we have 4 plus 2 plus 1 equals to 70, which gives us A multiplied to 7 divided by 4 equals to 70, or A value will be equals to 70 times 4 divided by 7. So 7 times 10 is 70. So we have 10 times 4. This is equals to 40. So that means our first term is going to be equals to 40. So our terms will be, the first term is 40, then we have 40 times R. So 40 times half will be 20. And then 20 times half will be 10. So these are the 3 numbers, 40, 20 and 10. These are in geometric progression as well.